These are our equivalent ratio notes or proportions. So equivalent ratios represent the same part-to-part or part-to-whole relationships. And then just a reminder, equivalent means equal. So you have to be making ratios that are equal. So the numbers might look different, but they do have to represent the same part-to-part or part-to-whole relationship. A proportion is an equation that shows two equal ratios. So it is just a way to write out the problem to help you solve for that missing value or to create those equivalent values. To solve a proportion or to create equivalent ratios, you can scale up, which means to multiply, or scale down, which is divide, both values by the same number. This process should sound familiar because this is exactly what we use to create equivalent fractions. That is one of the reasons why we can write equivalent ratios or ratios in general in fraction form, because they show that part to whole relationship. So let's take a look at what we're talking about. So in example 1, we're talking about some muffins. So in one muffin variety pack, 2 out of every 5 muffins are blueberry. So question 1 says write the ratio of blueberry to total. And remember to use your labels. So when we learned to write ratios, we talked about how the order matters. The order needs to match the question, and then the labels will set us up for success in future problems. So here we have 2 blueberry muffins over the 5 total muffins. And so you can see right here in this picture, here's 1, 2 blueberry, and then there's 3, 4, 5 more. So 2 to 5. Now we're going to use this starting ratio to solve for the missing values in these other 2 practice questions. So we have how many muffins are blueberry if there are now 25 total. So we're trying to find the blueberry. So we're always going to start with our starting ratio of 2 blueberry to 5 total. Now they've given us this third number of 25 total. So because we have our labels, we know that the total values are going on the bottom. So this 25 has to stay in the denominator spot. So here we're going to turn a 5 into a 25. Up at the top, I reminded you, you can only use multiplying and dividing. So if I go from a small number to a big number, I'm going to have to multiply. So then the question is 5 times what equals 25? And that would be 5 times 5. Whatever you do to the bottom, you do to the top. So 2 times 5 is 10 blueberry muffins. For number 3, we now have 8 blueberry muffins, and we're trying to find the total. So same thing, we're going to use our starting ratio of 2 blueberry to 5 total. But now our blueberry muffins are going up to 8. So we're going to write that 8 on the top because that's where our blueberry muffins are being represented. So math-wise, we have to turn a 2 into an 8. So again, we went from a small number to a big number. So we have to be multiplying. So then the question is 2 times what equals 8? And that is 2 times 4. Whatever you do to the top, you do to the bottom. And 5 times 4, there would now be 20 total muffins. Okay, so reminder, you always write your ratios in the same order as the question. We are adding labels to help us set up the proportion correctly. And then we are using multiplication or division to find those missing values. So here in example 2, in a math quiz bowl tournament, one round focuses on speed. Only one student will be chosen to compete for their school to solve as many problems correctly in 20 minutes, and that seems important. The results from their practice round are listed in the table below. Which team member is the fastest at solving problems correctly? So who should we choose to represent the school? So if we want the fastest person, we're looking for the person that answered the most problems correct in the 20-minute time frame. But if you look at the table, none of them are currently testing for 20 minutes. So we're going to set up some proportions or create equivalent ratios to figure out who would be the best pick for our school. So we're just going to do the mathletes in order. So we have Kay, and her starting ratio is 4 problems in 5 minutes, but the competition is a total of 20 minutes. So here we have to figure out how to turn a 5 into a 20. We got bigger, so we know we're multiplying. 5 times 4 is 20. Whatever I do to the bottom, I do to the top. So 4 times 4 is 16 problems. So Kay's number is 16. Next up, we have Susan. Susan can solve 7 problems in 10 minutes. So 7 over 10 is her starting ratio. But the competition is 20 minutes. So again, we have to turn a 10 into a 20. We got bigger, so we're multiplying. And then 10 times 2 is 20. Whatever we do to the bottom, we do to the top. 7 times 2 is 14 problems. So right now you have Kay at 16 and Susan at 14. So the faster person right now is Kay because she has more problems correct than Susan. Up next is Doug. Doug's starting ratio is 1 problem in 2 minutes. The competition is 20 minutes. So we have to turn a 2 into a 20 by multiplying by 10. Whatever I do to the bottom, I do to the top. So Doug could solve 10 problems. 10 is not more than 14, and it is not more than 16. So sorry, Doug, you are not representing our campus. Last up is Mako. They can solve 3 problems in 4 minutes, but the competition is 20 minutes. So how do we turn a 4 into a 20? We multiply by 5. Whatever I do to the bottom, I do to the top. So they sneak in second at 15 problems. So the fastest person, or the person answering the most problems correct, is Kay. So we would pick Kay to represent the school. Now, all of the problems so far have used multiplication, but that is not the only way to create equivalent ratios. So let's take a look at some more practice problems and see if we can find a couple that actually require division. So number 1, the Johnson family took a road trip. They drove 720 miles in 12 hours. If they maintain the same speed, how many miles did they drive in 4 hours? Okay, so our starting ratio matches the order of the problem. So 720 miles in 12 hours. But we want to know how far they went in just 4 hours. So from here, I'm turning a 12 into a 4. This time I did get smaller, so I have to divide. So 12 divided by what equals 4? And that answer is 3. So then 720 divided by 3, oop, that's not a very good arrow, but is 240 miles. If you wanted to see that division, here is your 720 divided by 3, 2 times. Left with 1, bring down the 2. 3 times 4 is 12. There's a 0 left here, so I need to put that 0 in the 1's place. All right, problem number 2. They gave us a table full of ingredients and some words. So the ice cream shop uses the following ingredients to make a single sundae. So that means all of our starting ratios are going to involve that one sundae. So how many sundaes, that's what we're looking for, did the shop make if they used 32 spoonfuls of sprinkles? So our starting ratio is 4 spoonfuls of sprinkles in 1 sundae. But we know they used 32 spoonfuls of sprinkles. So the question is, how do we turn a 4 into a 32? And that's times 8. Whatever you do to the top, you do to the bottom. So 1 times 8, they could have made 8 sundaes with 32 spoonfuls of sprinkles. Still using our sundae example in our table, we want to know how many scoops of ice cream, so that's what we're looking for, would be needed to make 12 sundaes. So again, with our starting ratio, we have 2 scoops of ice cream for every 1 sundae, but we want to make 12 sundaes. So then the question is, how do we turn a 1 into a 12? And that's times 12. Whatever you do to the bottom, you do to the top. So we would need 24 scoops of ice cream to make 12 sundaes. All right, keeping it going. Problem 3. 3 tickets to the movies cost a total of $26.25. How much does each ticket cost? So this one's written a little differently, but we have this 3 tickets for $26.25. So that's our starting ratio. 3 tickets, $26.25. And we're looking for the cost of each ticket, which is 1 ticket. So how do we turn a 3 into a 1? We divide by 3. Whatever you do to the top, you do to the bottom. So $26.25 divided by 3. So that's a 0. And then an 8. So 26 minus 24. Now I have 22 times 7 minus 21. Now I have 15. That's 5. And we're done. So each ticket costs $8.75. Seems like a good deal. 2 to go. Question 4. To make orange paint, you need a ratio of 1.5 gallons of red to 1 gallon of yellow. If there's 3 gallons of yellow, how much red paint would you need to make the same shade of orange? Okay, so our starting ratio, we have 1.5 gallons of red and 1 gallon of yellow. The yellow, which is in our denominator position, is going up to 3. So how do we turn a 1 into 3? And that's multiplied by 3. Whatever we do to the bottom, we do to the top. So 1.5 times 3 is 4.5 gallons of red. And last but not least, you are throwing a birthday party and need 3 liters of soda for every 7 guests. If you have 28 guests, how many liters of soda will you need? So our starting ratio is 3 liters for every 7 guests. The guests are going up to 28. So how do we turn a 7 into a 28? We multiply by 4. Whatever you do to the bottom, you do to the top. So you would need 12 liters for the party. Okay, so summarizing our notes for today. Equivalent ratios are found by using multiplication and division. Whatever you do to the top, you have to do to the bottom. You want to make sure you're converting the same type of number into itself. So guest into guest, liters into liters, cars to cars, trucks to cars, whatever the problem says. And then you don't have to worry about simplifying. You're just always looking for the missing value in the problem.